Welcome to this next video lesson. Make sure you have paper and pencil out ready to copy in order for you to understand this lesson fully so you can use these notes in this video lesson to do your worksheet. All right, and to be able to solve special right triangles. So, that being said, the name of these notes are called special right triangles 45, 45, 90. Right? Now, the reason these notes are called 45, 45, 90 is a 45, 45, 90 triangle is a special right triangle that has two 45-degree angles and one 90-degree angle. Okay? And right in the middle here, we have one. This pink triangle. We have two 45-degree angles. So this angle is 45 degrees, and that angle is 45 degrees. And then we have one special 90-degree angle. So it's called 45, 45, 90. Right? So when that happens, since these two angles are equal to each other here, then these two sides, which we call the legs, are equal as well. That's why we have a 1 and a 1 here. Now, the hypotenuse, which is across from the 90, right? We know that. The hypotenuse is radical 2. Right? Radical 2. So when the hypotenuse is radical 2, the legs are both 1s. See? And this is for a 45, 45, 90 triangle. Okay? Now you'll see how we're going to use this information in order for us to solve our work. Okay? Next set of notes say, use proportion to find missing sides. Okay? We're going to use proportions to find missing sides. So, let's take a look. Our our instructions say find the missing side lengths. Right? Ends with an S, plural. Leave your answers as radicals in simplest form. Okay, so let's take a look what that looks like. So we have our first example here, right? And as you can see, we have a 90-degree angle there. So this is 90 degrees, right? So this is a 90-degree angle. So I know that's 90. And we have 45 right here. So that means that this is 45 as well. So this is a 45, 45, 90 triangle. 45, 45, 90 triangle, right? So the parts of this triangle are similar to the parts of that triangle. That means that the hypotenuse, right? The hypotenuse is across from the 90. The hypotenuse is across from the 90. That means that A connects with radical 2, right? And as a matter of fact, let's do this. Watch what I'm going to do in order for me to make things clear here. So I am going to make this a little smaller. I'm going to make this red here. And then I'm going to make these two blues. Just like that, because both of those legs are the same. So in this triangle here, this is a leg and this is a leg, and the hypotenuse is A right here. So we're going to use proportions. So what connects with what, everyone? What connects with what? Right? So we're going to say A connects with radical 2. Those are the two hypotenuse, right? So we say A over radical 2. And that is equal to, let's see, the bottom of the triangle, 17 connects to 1. Look at that, right? So I'm going to say 17 connects with 1. So here we cross multiply, right? We're used to cross multiply, butterfly multiply. 2 times radical 2 times 17 and 1 times a. Well, the easy one is 1 times a is 1a, right? So we're going to get 1a is equal to 17 times radical 2. Well, this is a radical and this is a regular number, so they don't multiply. So what we do is we put them right next to each other. So we get 17 radical 2. Well, the opposite of multiplying by 1 is dividing by 1. So I get a is equal to 17 radical 2 divided by 1 is 17 radical 2. And there you go. Look at that. I have found my a. A is 17 radical 2. But I need to find my b. It says find the missing side lengths. Okay? Find the missing side lengths. So what I'm going to do is I'm going to make this, let me see if I can make it a little smaller here. So make that a little, oops. So let me make this a little smaller so I have room. My bad there for making it so there. Look at that. Okay. So let me erase this. And I use blue here on this one. This is blue, right? So I found A. So now I need to find B. Okay. So wait a minute. Look at this. The bottom here is the same as the side. So whatever the bottom is the side. Whatever the bottom is the side. Wait, what? So B is equal to 17. And there we go. Look at that. I have found both sides. Right? I have found A. A is 17 radical 2. And I have found B, 17. Perfect. I found my missing side lengths. Okay. There you go. Look at that. We use our 45, 45, 90 triangle there, and we compared it to the question. So let's do the same thing here with our second example, right? So again, we're going to identify our 90-degree angle here, right? So this is our 90-degree angle. And we're going to find the hypotenuse goes across, right? So, and this one is also a 90-degree angle here. And our hypotenuse went across as well, just like that, right? So that means that our red is right here. So that means that our legs are blue and blue. So our legs are blue and blue. Okay? So let's compare. Let's do some comparisons. So 19 radical 2 is similar to radical 2, right? Red to red. So 19 radical 2 is similar to radical 2. Is equal to x goes with 1. Look at that. X goes with 1, right? Blue goes with blue. So x goes with 1. Okay? So now I cross multiply radical 2 times x and 1 times 19 radical 2. Okay? Well, 1 times 19 radical 2 is just 19 radical 2. 19 radical 2 is equal to radical 2 times x is radical 2x. Just like that. Right? Well, this is multiplying. The opposite of multiplying by radical 2 is dividing by radical 2. Right? And look what happens to these two right here, guys. Radical 2 divided by radical 2 cancel each other out. So I am left with 19 is equal to x. Right? There you go. Look at this. I have found x. My x is 19. Perfect. But wait a minute. What do I notice here? Blue and blue are the same. So whatever this is, x is, y is also. So if x is 19, that means y is also 19. So I can write here, y is equal to 19. And there you go. Look at that. I have found x is equal to 19 and y is equal to 19. Perfect. So there you go. These are the two kinds of examples you're going to see in the worksheet, right? Special right triangles 45, 45, 90. You have to use our 45, 45, 90 triangle right there, right? In order to compare with your triangles. And you're going to use proportions, right? Fractions equals each other. You're going to cross multiply and you're going to find your missing stuff. Remember that the blue and the blue are the same. The legs are the same. So whatever one leg is, the other leg is equal. Okay? So make sure you copied everything down. You got everything in order. And now you are ready to go for this really cool assignment. All right? Thank you for being here. I'll see you next time.